Hello, today we're looking at area, perimeter and volume. Now, as we're coming to the end of this academic year, we're going to be reviewing our knowledge and looking at the connections and the differences between them. Okay, so first of all, area and perimeter. These can be done with both 2D and 3D shapes. Volume, however, must be done with a 3D shape. It can't be found with a 2D shape, and we'll come on to why later on. Right, perimeter first of all. Now with perimeter there is a lovely piece of alliteration that the perimeter is the path and we plus. Okay. There are various other methods for perimeter, but essentially it is the path around the outside of the shape. It does not matter if the shape is a straight line, if it is a curved line, but it is the path around the outside of a shape. Okay, and there we would add together all the bits. Likewise, we can also use this knowledge that if we know that I take a flattened L shape, and if we know that this side here is 10 centimeters, this side here is 7 centimeters, this side here is 4 centimeters, and this side here is 1 centimeter, we can find the missing sides, because we know if these are all right angles, it means that these three sides are parallel and these two sides are parallel. To put it into full notation, it means a parallel oops, very badly highlighted, a parallel, and we would use an arrowhead notation. Now I will go over this in more depth in the live lesson as well. Therefore these three are parallel and I use arrowheads on those. It does not mean they are the same length, but it means that they are parallel. Because of this, it means if we know that that is 10, that part there is 7, what do we add to 7 to get to 10? We add 3 centimeters. Same principle here. If that is 4 centimeters, that is 1 centimeter. This side here must be 5 centimeters. Now, obviously, this is just a quick sketch. It is not drawn to scale, but we can use our knowledge to find things out. Okay, so the perimeter is the path around the outside with we plus. Now, when we look at perimeter, the units we use are always standard units. Okay, centimeters, meters, kilometers, millimeters, etc. Okay, they have no indice on them, they are just a standard unit. Whereas area, A-R-E-A, hope you can spell Mrs. Patmore, always has units which are squared. For example, centimetres squared, kilometres squared, metres squared, millimetres squared, etc. And this squaring is because of the calculation involved. Now, depending on the shape of the area, the actual formulae for the area will change. And we will look at this in more depth in another video later on this term. But essentially, somewhere along the line with area, we are going to be doing some sort of multiplication. And with area, it's the amount of space inside the shape. So if I take something like this as a simple rectangle, and I tell you this side here is 3 meters, that side there is 4 meters, looks like millimeters, my apologies, let's rewrite that, meters. The space inside the shape is the area. The perimeter is the path around the outside, the area is the space inside. 3 multiplied by 4 is 12 metres squared. And that units squared, or square metres, can be said both ways around, means that it is the space inside. So if I'm finding a shape which is measured in kilometres, it's kilometres squared. If I'm finding a shape in metres, it's metres squared. Millimetres squared, because of this multiplication involved somewhere. Now, it is not that you just multiply the sides together. It does not work like that. But there is always some sort of multiplication involved when finding area. The final one that we're looking at is volume. Now, obviously, I can't draw this on the paper. So we're talking about this. I've got a box as an example. So when we're talking about volume, we're talking about the amount of space inside the box. Now, this is a standard shape. It's a cuboid, and it's relatively easy to find the volume inside by measuring each of the dimensions and multiplying together. Likewise, I can also find the volume of a bottle. Now, you don't just multiply the dimensions together with this, it is far more complex. But if essentially, because it is a 3D shape and you can pick it up, you can hold it, hence me not being able to draw it, as soon as we come onto volume, the units are cubed. So we could have millimetres cubed, centimetres cubed, metres cubed, kilometres cubed, etc. Because the 3D shape has the 3 dimensions, and it's because of that we get the cubing. So volume is always units cubed, area is always units squared, and perimeter is always just the standard units. Now, earlier on I said that with 3D shapes we can also find perimeter and area. Maybe it's not quite as clear on this, but if I was to find just the area of this one side, that would be relatively straightforward. Likewise, I can find the area of this side and the area of the top side too, close up on my fingernails. So what we can do is we can find on a 3D shape something called surface area, i.e. the amount of space on the outside of the shape. Likewise, we can also find the total amount of edges, and this is using perimeter. Okay, again, you can't just do one simple calculation. You've got to work out each part, work out each part, work out each part. But we can use that information.